In section 2 of chapter 3, we are going to look at we're going to look at describing data using measures of variation. So now we can talk about the range again, which we did utilize before when we were constructing those group frequency distributions. We'll be able to talk about the variance and the standard deviation and how those numbers describe the variability in data. So first, we know from a previous unit and probably even before you've encountered the range, it's the highest value minus the lowest value. Oftentimes, if the range is far too large to describe the variability in the distribution, then statisticians use variance and standard deviation to measure variability. There is something that we'll also find to estimate the standard deviation, and it's called the range rule of thumb. So if we take the value of the range and divide it by 4, that is it can be a good estimator of the standard deviation. It may not always be very close, but it can be a good estimator of the standard deviation. So for this section, pretty much from now until probably the end, you'll be introduced to several different formulas that we'll utilize in certain sections and then throughout the course of throughout this course. And so for this particular problem, this is considered the shortcut formula for computing or for calculating the variance and the standard deviation. So if you notice, they are essentially the same, just one is the square root of the other. So in order to find the standard deviation, we have to first find the variance. And the variance just describes how much a random variable differs from its expected value. And in this case, the expected value that we look for is the average or the mean. And then a standard deviation is a number. It's basically it's also used to tell us how spread out it is from the expected value. So more or less, statisticians use the standard deviation to describe the typical spread or the typical variation each value is from the average. And so that's what we'll be able to discuss in this section. So we look at our first example. We have a sample of 12 drivers, and this represents the time that these 12 drivers spent in rush hour traffic in minutes. And we want to find the range, the variance, and the standard deviation. And we're also going to interpret the value of the standard deviation. And I'm going to show you 2 ways to find this. I'm going to show you how to do it by hand because the calculation is not too bad. But then I'm also going to show you how to find it using the calculator and Excel as well. So first, the range, we know that's the highest value minus the lowest value. And so in this case, the range is 22 minutes. That's the length of the spread from the highest value to the lowest value. There's a 22-minute gap from highest to lowest. Now we can actually take that number and we can find the range rule of thumb. So we divide that by 4 and we can use that to help us estimate the standard deviation. So if we take that 22 minutes and we divided it by 4, we get a value of 5.5 minutes, and that we'll see how close that is to the actual standard deviation, because this is going to be an estimate. This is going to be an estimate value that we'll use. So now we talk about variance and standard deviation. Variance and standard deviation are related to each other. The standard deviation is the square root of variance. So we have to find the variance first in order to get the standard deviation and then interpret what that standard deviation means. If our calculation for variance is off or incorrect, then that means our calculation for standard deviation will also be off and incorrect. The formula for variance, the shortcut formula, some of the notation we are familiar with, we've seen before, and I'll kind of go over that. N represents the sample size, so in this case, the 12 drivers. And then we only have to really find 3 bits of information to use this formula. We need to find the sample size, we need to find the sum of all of the data, so add all these 12 numbers together, and then we need to find the sum of the squares of the data. So we would take each value, square them, and then add that together. So first we look at the sample size. Well, the sample size is just the 12 drivers that the data represents. And then we find the sum of the data. That's adding all the numbers together, so 52 plus 61 plus 53, all the way to 59. And we do that, and it gives us 676. And that value is in minutes. So that's the total number of minutes spent in rush hour traffic for the 12 drivers. on a snowy day last winter. And then the third value we have to find is the sum of the squares of those values. So 52 squared, 61 squared, 53 squared, all the way up to 59 squared. And that value, 38,476. Once we find these three numbers, and that value is in minutes squared, but once we find these three numbers, then we can set up our formula and we can find the value for variance, and then we can in turn find the value for standard deviation. So once we are able to set this up, we have 12 times 38,476 minus 676 squared, and that's divided by 12, either times 11 or 12 minus 1. Now this is just a simple numeric calculation, so you can enter that in any calculator. I would be cautious about entering that into your cell phone, because you would have to make sure you use grouping symbols very accurately to find that value. But you can certainly enter this into your phone and see what you get if you haven't downloaded the Desmos app that I demonstrated earlier, or if you haven't downloaded the calculator that I'm using in the video. I'm trying to give you different options, so I'm showing you a couple of different ways to find it, not by hand, after I show you the hand way. So to get the standard deviation, I just take that same value, 33.8, and I take the square root of it. And so that value represents standard deviation, 5.99 minutes. And so if we look and we compare it to the range rule of thumb, the range rule of thumb that we got earlier was 5.5 minutes. So although they're not the same, they are pretty close. So this tells us that we can use this as an estimate of the standard deviation to kind of get an idea of the number we should get before we even calculate it. Now, to interpret this value, what does this value represent? Well, we look at, on average, excuse me, the typical, and this is about hours spent in rush hour, so the typical time spent in rush hour is going to vary about 5.99 minutes from the average time, and I calculated the average time. So the average time, if we remember from before, is we can take the 676 and divide it by 12, and that'll give us the average time. So the average time would be 56.3 minutes. So the typical time, or these values on average, vary about 5.99 minutes from the average of 53.6 minutes. So you look at the differences between the 53.6 minutes and each one of those values on average, it's approximately 5.99 minutes. So that's what the standard deviation represents. Now, I did want to show you how you can get that same answer not doing this process, because we will. Well, I'll just show you. So I've typed in the data in the list, in list 1. So I showed this in one of the previous lecture videos. If you go to stat and then edit, and I've already typed in the information. When we did the paired data, the scatter plots, but we only have one set of data, and that's the wait time. So this is univariate data, not bivariate data. It's only one type of data. I want to go back to stat and then to calculate, and we can't do linear regression again because we don't have two types of data. Instead, we'll do number 1, which is one variable statistic. I only have one type of data. So number 1, it's in the first list, and we can go down and calculate. And if you notice, it gives me the average, so 56.333 repeating. It gives me the sum of the x's, 676. It gives me the sum of the squares of the x's, 38,476. And it even gives the standard deviation. Now these, the s and this little Greek symbol sigma, those are both standard deviation, but s is for sample, which is what we primarily use, and sigma is for population, which we'll talk about much later. But so 5.99 if you round it to the nearest hundredth. That's one way you can find it. Another way you can find it, in your homework you can download all the data as an Excel spreadsheet. So I just typed it in because this wasn't a homework question. Or you might have a question like it, but it's not an exact homework question. And Excel has some very nice features or functions you can type in. So if I type in equals Well, first let's do, I meant to show you this in the previous lecture video for section 3.1, but I didn't. I'm not sure why. But if I have an equals mean, actually average, and then if I select all this data set, it'll give me the average, 56.33. I can even type in equals median. So I can start to type it in, and it gives me a description, returns the median or the number in the middle of the given set. So I have to hit tab for it to give me the whole entire formula, and then I can select all the data. So it gives me the median too. But if I want standard deviation, equals STD, so that might be easy for you guys to remember. P is for population, and S is for sample, so we want the S. Hit tab, and then I want to select all this data, so it gives me the same value. So that hand calculation is becomes far more manageable. Instead of doing this process, then you can easily use Excel to confirm your work, or you can use the calculator to confirm your work. But the process of finding it by hand is not too terribly tedious because we're using the shortcut formula. Now, we'll go back. So for this one, it says the data shows a price of silver and tin over a 9-year period. We want to find the standard deviation of each and then determine which distribution is more variable. So before we even get into standard deviation, because I'm going to use Excel for this problem, I'm not going to do that process by hand for this one. We can find the range first to determine which one is more variable. We can use the range as an indicator of spread. So the range for silver, we look at the highest and the lowest values for silver, so 39.19, 11.8, and we get a spread of $24.11. And then we look at the range for tin, we find the highest value, 15.01, and the lowest value, 5.8, and we find the range for tin, and we discover that, 10 is the least spread out of the two different metals. Range, the silver has a higher spread in this cost. So the silver would actually be a lot more variable because of the higher fluctuation in its values. And so we should expect when we find the variance and the standard deviation that silver should be more variable than tin. And so to illustrate that, we're going to use technology to actually find that, which is just we're going to use Excel to find that. And so I've already typed the data in here. So if I want to find the variance, equals VAR for variance, and then I want to select S for sample, tab, and then select silver, and then equals VAR, hover over S, and then tab, and select 10. So we can already see that 10 has a lower variance, which in return will be a lower standard deviation. I do equals STD, and then S, tab, select silver, and then equals STD, go down and select S, tab, and then select 10. We can see that silver's, our 10's standard deviation is a lot lower. So our silver is much more variable based on the standard deviation as well, in lieu of the range, than 10. All right. Now for our last example, similar into the way that we could find an average for a grouped frequency distribution, we can also find the variance and the standard deviation of group frequency distribution. And more or less that process is very similar. The midpoint is still here. The frequency times the midpoint column is also still there, but we have the additional column here, and that's largely due to this formula. This formula is very similar to the shortcut formula, which is why I chose to use it, because they essentially have the same setup. We have our sample size, which is the sum of the frequency, and then we have the sum of the frequency times the squares of the midpoints, which is this column here. And we have the sum of the frequency times the midpoint, which is this column here, squared divided by the the sample size times sample size minus 1. So very much the same format as the standard deviation before. It's just coming from a group frequency distribution. And so when we go through the process of finding the standard deviation, when we interpret it, it has a similar interpretation as a standard deviation of ungrouped data. And so we find the midpoint first. We know that the midpoint for each of these class boundaries is the lower bound plus the upper bound divided by 2. So this 7.5 plus 12.5 is 20, divided by 2 is 10. And then the 12.5 plus 17.5 is 30, divided by 2 is 15. So we get all those values. Now we don't really need, we need the midpoint for both this column and this column, because this is their frequency times the midpoint, and this is their frequency times the squares of the midpoint. So to find this column, it's essentially frequency of 3 times midpoint of 10, and then frequency of 5 times midpoint of 15, and then frequency of 15 times midpoint of 20, and so on. And we get that. Now, after we find that information, if we look over at our formula here, we are going to need to sum that information. So we need the sum of this column. So we're going to add all that together with the sum. And then we kind of repeat that same process in this column, follow the instructions of the frequency. So 3 times the midpoint squared. My midpoint is 10, so 3 times 10 squared. And we get that information so that we can find the sum, and that represents this value here. So 15 times 20 squared, 6,000. And then 5 times 25 squared, 3,125. After we get all our values, we're going to sum this column together, and we're going to get 12,350. And so just like when we found the standard deviation and the variance before, we just need 3 bits of information. We need this number, the 590, that goes here in our formula. We need this value, the 12,350, that goes here in our formula. And then we need the total frequency, which is the sample size, which is the 30 automobiles. So we need that value as well. Once we substitute in our values, then we can calculate or determine what the variance is. So once we've substituted our values, we get the variance of 25.75, and this value is miles per gallon squared because the variance is squared. And when we take the square root of that, we get the variance, or we get the standard deviation, which is 5.7 miles per gallon. And we look at, well, what does that really mean? What does that tell us? Well, on average, the typical fuel efficiency for these vehicles varies by approximately 5.07 miles per gallon from the average fuel efficiency for all of the vehicles, which was 19.7 miles per gallon. So if we knew the 3 values in this interval and the 5 values in this interval, and we compared each of those 30 values to the 19.07, on average, they vary by about 5.99 miles per gallon. So that's what the standard deviation tells us. And for this section or unit, that would be all of which you would be expected to do in the homework. They're not going to ask you to interpret the standard deviation, but I think the interpretation is important so you can know what that value represents.